Hi friends, in this video we will understand the use of differentiation for determining the slope of tangent to y versus x curve or the slope of normal to y versus x curve. Hence, be ready with your pen and notebook to make notes for your future reference. If we plot a graph between y and x, say the value of x is changing from x to x plus delta x, such that the value of y is changing from y to y plus delta y, and the points xy and x plus delta x, y plus delta y are represented by a and b. Then from point A to B, change along vertical axis, that is delta y is represented by bn, while corresponding change along horizontal axis, that is delta x, is represented by an. And we know that perpendicular upon base, that is delta y by delta x, will give the slope of secant to the curve passing through points A and B. Thus, delta y by delta x, that is total change in y upon total change in x, which is also called average rate of change of y with x, will always represent the slope of secant to the curve passing through the points A and B. Also, if delta x will approach to 0, then point B will approach to A. Hence, this secant will approach to the tangent to y versus x curve. Hence, under the limit delta x approaches to 0, delta y by delta x becomes dy by dx, that is differentiation of y with respect to x, and differentiation of y with respect to x will represent the slope of tangent to y versus x curve. Thus, differentiation of y with respect to x will always give the general expression for slope of tangent to y versus x curve. If dy by dx is giving slope of tangent, then to determine slope of tangent at a particular point, that is for a particular value of x, then we will put that value of x in the expression for dy by dx. So slope of tangent to y versus x curve will be given by dy by dx, as a line perpendicular to tangent is always termed as normal. So normal to y versus x curve will always be perpendicular to the tangent to y versus x curve. And since dy by dx gives slope of tangent, so slope of normal will be given by -1 upon slope of tangent, because the product of slopes of two mutually perpendicular lines is always -1. So slope of normal to the y versus x curve, m will be -1 upon slope of tangent to y versus x curve, and slope of tangent to y versus x curve is dy by dx. So slope of normal will be -1 upon dy by dx. Now we will understand the use of differentiation in determining slopes of tangent and normal to y versus x curve through some examples. Say the first example which we are taking is to find equation of tangent to the curve y is equal to x square minus 2x plus 7, which is first parallel to the line 2x minus y plus 9 equal to 0. Second, perpendicular to the line 5y minus 15x equal to 30. In part A of the question, the given line is 2x minus y plus 9 equal to 0, and tangent to the curve is parallel to this line. So the given line can be written as y is equal to 2x plus 9, and this implies slope of given line m is equal to 2, because it is in the form of y is equal to mx plus c. Since tangent to the curve is parallel to this line, so slope of tangent to the curve should also be 2, and we know the slope of tangent to the curve is given by differentiation of y with respect to x. So slope of tangent to the curve, say m dash, that will be equal to dy by dx, and dy by dx means differentiation of y with respect to x, that is 2x minus 2 plus differentiation of constant will be 0. Since these two lines, that is tangent to the curve and the given line, are parallel, so m must be equal to m dash. This implies 2x minus 2 must be equal to 2, implies x must be equal to 2. It shows that for point at which the tangent to the curve will be parallel to this line, the value of x will be 2. If value of x for that point at which the tangent to the curve is parallel to this given line is 2, then substituting this value of x in the equation of curve, we can find out the corresponding value of y. So the corresponding value of y will be y is equal to 2 square, that is 4, minus 4 plus 7, implies y is equal to 7. Thus 2, 7 is the point on curve y is equal to x square minus 2x plus 7, at which the tangent to the curve is parallel to this line. Now we want to find out the equation of this tangent. Since tangent is passing through this point and the slope of tangent is equal to slope of line, that is 2, so using point slope form we can find out the equation of tangent. So equation of tangent, y minus y1, y1 means 7 is equal to m, m means slope, that is 2, x minus x1, x1 is 2, so this implies y minus 7 is equal to 2x minus 4, or 2x minus y is equal to minus 7 plus 4, that is minus 3. It is the required equation of tangent. Now in second part we have to find the equation of tangent when the tangent is perpendicular to this given line. Since the given line can be written as 5y is equal to 15x plus 13, that is y is equal to 3x plus 13 by 5. This implies slope of given line m is equal to 3, because again this equation is in the form of y is equal to mx plus c. If slope of given line is 3, then this implies slope of perpendicular to this line will be, say, m1 equal to minus 1 upon n, that is minus 1 by 3. Since the tangent to the curve is perpendicular to this line, So this time slope of tangent to the curve must be equal to minus 1 by 3. Already we have calculated the slope of tangent to the curve, that is 2x minus 2. So for tangent to be perpendicular to given line, the slope of tangent, that is 2x minus 2, should be equal to the slope of normal to this line. So slope of normal to this line being minus 1 by 3, 2x minus 2 will be minus 1 by 3. This implies 2x is equal to 2 minus 1 by 3, implies 2x is equal to 6 minus 1, yani 5 by 3, implies x is equal to 5 by 6. It means 4 point on y is equal to x square minus 2x plus 7, at which tangent will be perpendicular to this line. The value of x will be 5 by 6. Now again, by putting the value of x as 5 by 6 in the equation of curve, we can find the corresponding value of y, and that value of y will be x square, that is 25 by 36, minus 5 by 3 plus 7. This will give LCM 36, 25 minus 60 plus 36, 7 ja 252, and this will give 217 by 36. These values of x and y are corresponding to the point on given curve at which tangent will be perpendicular to this line. Now if we want to find out the equation of tangent, then tangent will be passing through this point for which x is 5 by 6 and y is 217 by 36, while the slope of tangent will be equal to the slope of normal to this line, and slope of normal to this line is minus 1 by 3. So we will again use point slope form to find the equation of tangent. So by slope point form, the required equation will be y minus y1 217 by 36 is equal to slope minus 1 by 3 x minus x1, that is 5 by 6. Here y and x are current coordinates used to form the equation. If we will multiply both sides by 36, it will become 36y minus 217 is equal to minus 12x, and minus minus plus 10. This implies 12x plus 36y minus 227 equal to 0. This will be the required equation of tangent to y is equal to x square minus 2x plus 7, which will be perpendicular to the line 5y minus 15x equal to 30. Now we are taking one more example to use the derivatives for determining slopes of tangent and normal to the curve. Say this time the curve is y is equal to 4x cube minus 2x to the power 5, and we have to find all points lying on this curve on which tangent to the curve will pass through the origin. In this case, first we will have to determine the equation of tangent, and for determining equation of tangent we must be having the slope of tangent. And we know the general expression for slope of tangent to the curve will be given by dy by dx. Hence, general expression for slope will be dy by dx. And dy by dx means 4 into 3x square minus 2 into 5x to the power 4. This is equal to 12x square minus 10x to the power 4. If point on curve at which tangent to the curve passes through origin is AB, then it means the tangent is passing through this point, and since tangent is passing through this point, slope of tangent at this point will be found by replacing x in this expression with a. So slope of tangent to the curve at this point m will be 12a square minus 10 a raised to the power 4. Now slope we are having, the point through which tangent passes also we are having. So by point slope form we can find out the equation of tangent, and that equation of tangent will be y minus y1, that is b, is equal to m 12a square minus 10 a to the power 4 into x minus x1, and x1 is a. Since this tangent passes through the origin, so origin should satisfy the equation of tangent, that is 0 minus b must be equal to 12a square minus 10 a to the power 4 into 0 minus a, and this implies b is equal to 12 a cube minus 10 a to the power 5. As this point AB lies on the given curve, so the point will satisfy the curve, that is b must be equal to 4 a cube minus 2 a to the power 5. From these two equations we will get 12 a cube minus 10 a to the power 5 equal to 4 a cube minus 2 a to the power 5, and this implies 8 a cube is equal to 8 a to the power 5. This implies 8 a cube into a square minus 1 equal to 0, and this implies either a cube is equal to 0 or a square minus 1 equal to 0, implies a is equal to 0 or plus minus 1. For a is equal to 0, y will be 0. It means first point will be 0, 0. For a is equal to minus 1, y will be 4 into minus 1 minus 2 into minus 1, that is minus 4 plus 2. This is equal to minus 2. So second point will be minus 1 minus 2. Now the third possibility is a is equal to plus 1. So for a is equal to 1, y will be 4 into 1 cube minus 2 into 1 raised to the power 5, and 4 minus 2 will give 2 only. So third point will be 1, 2. It means there will be 3 possible points: 0, 0, -1, -2 and 1, 2, at which tangent to this curve will pass through the origin.